So today we're continuing our focus on probability. Now we're going to look at compound events, or the probability of multiple events occurring at the same time. So far we really haven't been concerned about all of the possible outcomes and the sample space. Even when it was one event, all the outcomes for rolling a number cube, 1, 2, 3, 4, 5, 6, that is really the sample space. We didn't spend time focusing too much on that because it's easy to keep track of all of the outcomes because it's one event and we're well trained in that. But now that we're going to be considering more than one event at a time, we really need to start paying attention to sample space and how do we figure out all of the outcomes of more than one event happening. So we can use a tree diagram, which is something you're familiar with from doing prime factorization, creating tree diagrams. And so you randomly choose a crust and style of pizza, find the sample space, how many different pizzas are possible. So you start with, so there's crust, thin crust, stuffed crust, and style, Hawaiian, Mexican, pepperoni, and veggie. You pick one of the two options to start with. They chose crust, I think just because it was first. And you list all the options for crust, thin and stuffed. And then once you have all the crust options labeled, you start building the tree off of that starting point. And now you do the style. So once I know that I want a thin crust pizza, then I can pick it, make it Hawaiian, Mexican, pepperoni, or veggie. Same for stuffed crust. If I chose stuffed crust, I then can make it Hawaiian, Mexican, pepperoni, or veggie. So the way to count the number of outcomes is to count the words written at the very end. So 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 outcomes. And the way you read it is just kind of how they've shown you here. You used to go thin, Hawaiian, thin, Mexican, and so on. You just follow the branches of the tree. You're not going to be required to write all of these outcomes, but it's showing you how you read the tree. And then you guys did this in class. They added deep dish, so you created the sample space and told me how many pieces are possible. I told you could abbreviate, but please be very careful. If the same letter occurs more than once, you have to make sure to distinguish between them somehow. And if there's an S here and an S in the second, that's also the same letter appearing twice. How do I know which S represents what? I mean, if I have the chart, I can figure it out, but don't leave it to interpretation. Some of you are like, but I can see I can just multiply, and you can, but somebody came up with this rule because they noticed this pattern. We can't just use 2 small examples that happen to work and call it a rule and say, well, I'm just going to do that every time. But there is a rule, and it's called the fundamental counting principle, and it states that an event M, like crust, has M possible outcomes, 3 in our case, deep dish, thin crust, and stuffed crust, and that an event N, style, has N possible outcomes, 4, the Hawaiian, Mexican, pepperoni, and veggie. And you can find the total number of outcomes by multiplying each set of outcomes. So 3 times 4, and that's 12. So 12 outcomes. So you can see how that matches. So it's kind of the shortcut, but the shortcut is born from the idea of these diagrams or these trees that were created. So find the total number of possible outcomes of rolling a number cube and flipping a coin. Our first method is the table, which is always there, or the tree. The second method is that fundamental counting principle. So you treat each of these as separate events, and if I said, well, how many outcomes are there from rolling a number cube? You would have said, you told me 6. How many from flipping a coin? 2. And then the principle tells me to multiply these 2 values, so 6 times 2 is 12. So there's 12 possible outcomes from doing those 2 events together. And then you guys wrote this down in your notes. I said just make a very basic spinner, but you treat each event separately. So the number of possible outcomes of spinning the spinner, 4. Choosing a number from 1 to 5, 5, because I have 1, 2, 3, 4, and 5. And then I multiply those 2 events and I get their combined outcomes, 20 outcomes if they happened at the same time. And the fundamental counting principle doesn't work if it's only 2 events. You can do it for as many events as possible, or as many events that are given. So how many different outfits can you make from the t-shirts, jeans, and shoes in the closet? Well, t-shirts have 7 outcomes. 1, 2, 3, 4, 5, 6, 7. Jeans have 4. 1, 2, 3, 4. And shoes have 3. 1, 2, 3. I have my numbers, and the counting principle says multiply them, so I multiply them, and I get 84 outfits. We talked about how this is why the principle is useful, because we wouldn't want to have to create a tree diagram that at the end had 84 things written, and depending on how you decided to sort it, there's a lot of room for error, and that's a lot of time. So you guys looked at this closet and you figured out how many different outfits you can make from 4 t-shirts, 5 pairs of jeans, and 5 pairs of shoes, and that's 100 outfits. So compound events then are two or more events. Makes sense, kind of what that word compound means, two or more. And all of the things we've seen before would be compound events if we wanted to find the probability of them. And here's another example, drawing a card from a deck of cards and flipping a coin. Finding the probability of a compound event can be tricky because now you have to account for two separate things. So it's not just saying, oh, rolling a cube, that's 6 outcomes and writing 6 for the denominator. You're going to have to use the fundamental counting principle for rolling a number cube and flipping a coin to get the total outcomes. Tomorrow you're going to learn a different way to figure out the number of favorable outcomes or the total probability through multiplying. But for now, to find the number of favorable outcomes, you're either going to just have to mentally think about which things satisfy this or create a tree and find all the options that match. But a number greater than 4, well, on a number cube, that's 2 options, 5 and 6. And then if I flipped a coin, I wanted tails to go with that. So I want to get 5 and the coin to say tails, or I want to get 6 and the coin to say tails. So 5 tails is one outcome that matches, 6 tails is another outcome that matches. So there's only 2 out of the 12 that match the requirements, or 1/6. So we did this on probability of rolling at most 4 and flipping heads. So it's the same cube, 12 outcomes for the cube, 2 for the coin, or 6 for the cube, sorry, 2 for the coin. I think I said 12, so 12 outcomes. And at most 4, well, on a number cube, I have 4 options, 1, 2, 3, 4, and then I want the coin to say heads, so I can have it say 1 and then heads, 2 and then heads, 3 and then heads, 4 and then heads. So of all 12 outcomes, only 4 of them satisfy these set of rules. So 4 out of 12, or 1/3. Coins are a different story, and they become really tricky. You can still find the number of possible outcomes by multiplying. So 3 nickels, 2 times 2 times 2 is 8 total outcomes. But to figure out at least 2 heads and 1 tails, a tree diagram I think is about the only way most of you are going to be able to organize this information to see the pattern. And we talked about how this is nickel 1, heads or tails, and then if nickel 1 lands heads, my second nickel can land heads or tails, and if the second nickel lands heads, then the third one could land heads or tails. But if I go back, the second nickel could have landed tails, and then from there, the third nickel could have landed heads or it could have landed tails. And then you follow the tree, so H, 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 T, H, T, H, H, T, T, to create the list of outcomes. So it's just following the pattern of work to get that list, but then the one that satisfies 2 heads and 1 tail is 3 of them out of 8. And then this example, flipping at least 2 tails, we just went back to this instead of recreating it, and we looked at our list, and the ones with the stars, 4 have at least 2 tails, so that means 2 or more out of 8, or 1/2. This one I wanted to talk to you about because 2 number cubes sometimes becomes tricky for us to think about, and it says rolling double 3s, and you guys know what double 3s is. I asked every class and you all told me getting 2 3s. So if I roll a number cube, I have 6 outcomes on the first one and 6 outcomes on the second one, so it's a total of 36 outcomes. For the first number cube, if I wanted to say 3, there's only one way for it to say 3, 3. The second number cube, if I wanted to say 3, there's only one way for it to say 3, and that's 3. And so if I want the dice to look like this, this is the only way it can look like double 3s. So there's only one outcome that would show 3 on both number cubes. The reason why you would have more than one outcome is, say it wanted a 1 and a 3. Well, your first cube could be 1, your second one 3, and your first one 3 and your second one 1. Each of these is a unique outcome that satisfies having a 1 and a 3 on your number cube, so that would be 2 outcomes. And we talked about how Yahtzee, that's why it's really hard to get Yahtzee when you play, because there's one chance of getting 5 numbers the same out of 6 times 6 times 6 times 6 times 6. And then the probability of choosing a stuffed crust Hawaiian pizza, well, stuffed Hawaiian, well, there's only one option for me to choose stuffed and one option for me to choose Hawaiian, so there's one option out of 8 for this example for a stuffed crust Hawaiian pizza. And that's our quick review of compound events.